In this next part of the notes, we're going to first of all need the definition that we discussed on the bottom of the previous page where we talked about complex conjugates. The complex conjugate of a complex number or imaginary number, a plus bi, is a minus bi. Now let's just practice and make sure that we're clear on exactly what that is saying. So just basic example here. Let's say that I had the complex number 5 plus 3i. The conjugate of that number would be 5 minus 3i. So essentially, to find the conjugate of any imaginary or complex number, you just need to change the sign of the imaginary part. What if we had -2 minus 5i? In this particular case, the conjugate would be -2 plus 5i. So notice that the sign of the real part does not change. It stays the same. It's the sign of the imaginary part, in this case the 3i and the -5i, that actually changes its sign. Okay, now that we feel comfortable with that, let's see how we would divide complex numbers and then write our answer in standard form. And so looking at letter A, we have 2 plus 3i over 1 plus 2i. Now, the first step in this process is always to multiply this complex number of fractions by the conjugate of the denominator. And so if we zero in on the denominator here, that's 1 plus 2i, and the conjugate of that is going to be 1 minus 2i. Now, if I multiply by that in the denominator, I know that in order not to change the problem, I need to also multiply by it in the numerator as well. And so now what this turns into is just two multiplication problems like we saw on the previous page. And so in the numerator, we're going to distribute. 2 times 1 is going to give me 2. 2 times -2i will be minus 4i. 3i times 1 will be a positive 3i. And 3i times -2i will be a minus 6i squared. This is all going to be divided by 1 plus 2i times 1 minus 2i. But here's the beautiful thing about these problems. Notice that in the denominator, we are going to be multiplying conjugates together, and we discussed what happens when we multiply conjugates together back in example C on the previous page. Whenever we multiply two complex conjugates together, the imaginary parts are going to cancel and we'll just be left with a real part. And so here what we're going to do is multiply those first two terms, 1 times 1, which gives me 1, and we're going to multiply the last two terms, 2i and -2i, which gives me a minus 4i squared. And I don't actually need to multiply the middle terms, because if you'll look here, 1 times -2i would be -2i, and then 2i times 1 would give me positive 2i. And notice that that's going to cancel out, and that will always happen if you are multiplying two complex conjugates together. Now, what we're going to notice next is that we have I squared in two places here, and so we know to replace that with -1, or essentially just to make that term the opposite sign. And so this is going to become a positive 6. This down here is going to become a positive 4. And so in the numerator, what I notice is that I have a 2 and a positive 6. That's going to add together to give me 8. And then my imaginary terms in the numerator I have right here, and those are going to combine together in order to give me a -i. In the denominator, we're going to have 1 plus 4, which will give me 5. Now we want to write this in standard form, a plus bi. And so what we're going to do here is called splitting through the numerator to write this as two fractions. And so 8 over 5 minus 1 over 5 multiplied by I, that is going to be our final result. So again, what exactly did I do? I took 8 and I divided by 5, and then I took -i and divided it by 5 and just wrote it as -1/5 I. In the next example, we're going to do exactly the same thing. So we're going to start off by multiplying by the conjugate of the denominator in the numerator and denominator. And so the denominator's conjugate, we're going to change the sign of that imaginary part and get 3 plus 2i. And so I'm going to multiply by that in the top and in the bottom. So in the numerator, we're going to have some distribution to do here. 2 times 3 is going to give me 6. 2 times 2i will give me positive 4i. I times 3 will give me positive 3i. And positive I times positive 2i will give me positive 2i squared. This is all going to be divided by the multiplication of 2 complex conjugates, which means I only need to multiply the first 2 terms together, which is going to give me 9 when I do 3 times 3, and then negative 2i times positive 2i will give me a minus 4i squared. Now, I know that I squared is equal to negative 1, and so what I notice here is that I'm going to be able to change this term to a negative 2, and this term to a positive 4. And so what we're going to end up with here when we collect the like terms in the numerator as well, as I see that I have 2 like terms here that are both imaginary, and I also have 2 real parts here and here that I can combine, we're going to get positive 4 as our real part and 7i as our imaginary part, and that will be divided by 9 plus 4, which will give me 13. Now, to write this in standard form, again, we're going to split through the numerator, and so this will be 4 over 13 plus 7 over 13i as the answer whenever you divide those complex numbers.